Hello and welcome to another Solana Anchor tutorial. Today we're gonna have a look at how we can optimize our program to make it more CU efficient with the use of the remaining accounts. So this is a CU optimization, and as with any optimization, it comes with trade-offs. So I'm not saying that you should do it that way. I'm giving you options of things you can do if you want to squeeze out a few of those compute units from your program, make it more efficient. And in the process, we're just going to learn how Anchor works and revisit the transfer hooks from last times. So join me on this journey of playing around with Anchor. Let's go. I'm gonna go down here. How big do I want to be? Like this? How big am I usually? I reinstalled my computer, that's why everything is new. I need to set it all up again. Let me know if I'm too big or too small. You probably don't care. And then we will need this thing. Oh, damn, maybe I want to fix that first. Okay, let's quickly change that. I don't need this, and I don't need this. And I also don't want the user. I also don't want this. And then I want this as a just one. Let's see. Yeah, well, almost. Still got $1 too much somewhere. Yeah, no dollar. That's because the dollar debian. Yeah, let's see. Yeah, that looks good. That's how I want it. Good. So then we need an anchor program. And I think I'm just gonna work with what we did last time with the hooks. Let's go with a simple hook. I don't want you. Thank you. I can write code myself. Don't need this. So, what did we have here? So in case you weren't here for this, I did make a whole video series on transfer hooks. And in part 3, we created this hook that can have all sorts of weird constraints. I'm gonna throw away most of them and just check 1, that it's actually transferring, that it's being called from the token program, and we are currently transferring. We check that by this flag in that account. And then we read the decimals of the token and say only if it's a token or more do we allow the transfer. If it's less than 1 token, we error. So you always need to transfer at least 1 token. That's going to be my simple transfer hook, and that's going to be the one that I'm actually going to optimize. Well, optimize. I'm going to squeeze a few compute units by maybe, not doing so many checks. I mean, the compute units need to come from somewhere. But also by not doing so many deserializations that are not necessary. And we're going to do that with remaining accounts. But before we go there, we want the reference. So let's deploy this thing such that we have something to compare to. Okay, do I still have the captain? That path is actually the same. That should still work. But I'm going to do a new program. Do I have Solana keychain installed? I guess so. So that's the expensive hook. And then we're going to do an optimized hook. That's the 2 programs we're going to deploy. Yeah, sounds great. So start with this. My next question, do I have Anchor? Damn it, no I do not. Gotta reinstall everything. Do I have Rust C? Okay, I have Rust installed. Good, that's good to check. Cargo, install AVM. Perfect, nice. Install latest. It's already installed. Use latest. Now using Anchor 0.31.1. Cool. Does that work as well? This can lead to unwanted behavior. What? Anchor lang version and the current CLI version don't match. Why? Because here I am in 31.0. Well, we'll see. Found incorrect program ID in Anchor. Oh, you updated them now for me? You motherfucker. I did that on purpose. The CLI changes that because it found a different, or it created a different key pair here. But what I really want is my key pair there. So change that back and change that back. Interesting, I can't just do that. Cool. I'm gonna move the key. Copy the key. Which one was it? The eHook to target deploy key pair. There you go. Fixed it. Quicker than you were able to download this. So do we downgrade our Anchor version or do we upgrade our program version? I think we're gonna upgrade. I mean, what could possibly go wrong? Right? Nothing can go wrong. Anchor lang 0.31.1. Perfect. We had what? Anchor debug. Unused imports. Yeah, whatever. I don't care about that. Use of deprecated math. Use resize instead. This sounds like a dependency something again, because it might use stuff that is now deprecated. I'm not actively using that method, that's why. But yeah, whatever. It's fine. I'll just ignore the warnings. As you do. If it's not an error, it's not an issue. What download. And it also managed to compile the IDL or create the IDL, whatever. Okay, seems like we have a working anchor. That's cool. Let's go to DevNet and set the key to the captain. I'm gonna recycle the captain, who still has 2.4 sol. What if I do anchor deploy? 218 transactions, that sounds like a regular anchor program. Oh, write transaction failed. There was a problem deploying. Well, that's not particularly helpful. Let's check. But did something go through? A minute ago. So yeah, some transactions did go through, but they were all BPF loader write instructions. Oh, are you telling me that you created a buffer account and now I don't even have enough sol to do it again? Or for F's sake, anchor? Oh no, you were just missing one transaction. Okay, deploy success. There we go. The air, what did I call it? Inefficient? Why did I say E? What did the E stand for? I already forgot. The early hook, E-hole deployed. And just because I'm curious, this program that I got just deployed here, the executable data has 209 kilobytes, so 1.45 sol. That looks like a regular anchor program. Anyway, so my hook program is available. Oh, but should we add the functionality that we can create this extra metas account such that we can transfer with CLI? Yeah, I'm gonna steal that. I'm gonna, from the complex hook, I'm gonna steal that. I'm gonna just say it's an empty vector. Oh, you know what I need? Rust analyzer. Was it this one? Do you trust the publisher, the Rust programming language? But it doesn't have a lot of ratings. Yeah, it seems to be this. Okay, fine. I trust you. And it seems to be the one that I had installed that also comes down here. Perfect. Yeah, we got the Rust analyzer. How do you spell that? Okay, import that. System program create account. There you go. Basically, don't worry about it too much. What we're doing here. If you're interested in what we're doing, watch the videos on the transfer hook. Oh, for F's sake, I don't have enough sol. We'll just allow the creation of this extra metas list account. And how do we do that? Also that. I'm gonna steal because I did that one. I really want, I guess. Okay, then the app I need. Oh, I don't even have PNPM probably. I can do NPM. Oh, access denied. Sure. There we go. So now PNPM install GIL. That should give me all the dependencies I need. Right? Programs as well. Okay, system program ID is also in Anchor, but that's something different. You know what? That's the system program. I'm not gonna let you annoy me with this. So, all we're doing here is creating an instruction to our program. Good point, I need to change the address. And for a given mint, create this extra account metas account. So let's create a mint. How about token 1, token with the E hook. Sure, ignore case. There we go. And then later we'll do the one with the optimized hook. Love it. Okay, SBL token. Do we have that? Yeah. SBL token, create token with program 2022 and transfer hook this hook program. Did I do that right? I guess. And just for fun, let's say it's only got 3 decimals, just so we have something else. Just so it's important for us to actually read the decimals and not assume that it's 9 anyway. There we go. Okay, token created. SBL token create account for this token. SBL token mint a few of those tokens. It's all going super well. And now the transfer, SBL token transfer this token, one of it to the receiver. This is not gonna work. First of all, because I need to fund it, okay, because that token account doesn't exist. But also, account not found. This is the CLI complaining that this extra metas account doesn't exist. So we gotta initialize this extra metas. Yes, install TSX. Damn it, it's failing. No random values implementation could be found. What? Solana error crypto random values function unimplemented. I am missing some dependencies. But that's cool, I've never seen that error before. It's a Solana error. When we looked at the errors, we're like, when do you ever get this function unimplemented errors? Well, yeah, if the functions are implemented because we don't have those packages installed or whatever. However, I don't actually know which packages I need to install. Let's Google that real quick. One would expect that you just tell me what you need to install. No random values implementation could be. Well, good old vibe coding it is then. What am I working on? Solana program. This error. Sorry, my bad. I should have said TypeScript. One of the Solana libraries you're using tries to call the random variables, but you're running Solana code without Node.js or a polyfill for it. That is true, I am doing that. So I either need this polyfill or I guess I just, there you go, ts node initialize extra matters. Ah, that still didn't help. I thought now that I'm running it with node this would work. Install npm install crypto browser friend. Could have used pnpm. pnpm is more efficient, but that difference that makes. Try again. Still not. Maybe with crypto? No. Put this at the very top of your app. Okay, here it is. Does it fix it? There you go, vibe coding. Some dependency shit that I'll try to understand some other time. For now, I just want to send the transaction with this one instruction. That's what happened here. We've created this account. Now I can do the exact same thing as before with a transfer, and that should actually work this time. No. Oh, I know why, because wrong token. I created this for the wrong token. Here, this is the right mint. Create that account. There we go. And now, there we go. That's better. We were able to send a transaction that does a transfer. And our transfer hook program does get called. And it does do all those things. And it does check that we're transferring more than one token. Because if we try to transfer less than one token, let's say 0.1, then it's gonna fail because the transfer hook complains. Error 6001, transfer amount too low. Low amount. I like it. Okay, we are done with the setup. Great. Okay, and this thing on success takes, oh, it's even setting the compute pretty exactly. Takes a total of 31,000 compute units, where specifically my hook program, this one, if we check the logs here, it consumed 5559. So this is just from my hook. The CLI is requesting the exact amount of compute that it requires. That's fun. Somebody is optimizing things here. It's nice. And that's our baseline, 5559. We're gonna try to lower this a bit. And the way we're gonna lower this is, instead of all of the accounts that we define here and let Anchor do all the serialization and the checks and the parsing and everything, we are not gonna do any of that. Because do we really need to check all of that? I mean, those two were already unchecked accounts, so that's almost fine. But even, wait, I'll show you this. Even not doing the two unchecked ones will save us a little bit of compute. Except now it doesn't know where to take this from. Okay, fine, you can have that back. Just removing one of the accounts, it's not gonna save us much, obviously, because it's an unchecked account as well. Deploy success, transfer one token again. And now to compare, probably similar. The total is less because we don't create the ATA now, but here we still see our program. Wait, what? 3,900? What? That's odd. I mean, that's 1,000 compute. So there must be something else that we did now. Or am I reading those logs wrong? Because that's just what the inner program consumed, right? That's what the outer program consumed, including the inner program, I think. But that's just the CPI. And here, did it have to do anything else? Wait, what's the difference? Here it got that account, the EA5, and here it also got the account, but it did. Wait, this is too much of an improvement. I'm gonna, wait, yeah, no, this could actually be, because what it does is it derives that again. So this check here, this is the expensive stuff, probably. Let's try again. Build and deploy with that again, with this seed check, because yeah, it derives an account. Even though it's an unchecked account and we don't do anything with it, we still check that it's the right account that is being supplied here. So, I mean, especially since we don't do anything with that account, that's kind of a waste. Yeah. That alone is 1,500 compute units that we can save. Just by not doing this whole check here. So I could either, just remove the check. I can just not do the check. This will already improve a lot. Build and deploy, waiting for that. There we go. Send again. This alone will remove 1.5K, I guess, yeah, to 3,951 from the 5,559. And if I also don't do the unchecked account at all, then from the 3,951 I can get down to 3,9. Okay, that makes more sense. So that's 40 to 50. That's 12 compute units that I save by not doing the unchecked account, because an unchecked account, it literally doesn't check anything, but it still reads the account. It still, gives me the pointer to the unchecked account. And even that I can save if I don't need it. I mean, it's just 12 CUs, but it's 12 CUs, right? If I don't work with that account, why would I put it in my accounts list? Because in my instruction, I'm not doing anything with it. So why would I even, deserialize and read that? That's absolutely useless. The token program will give it to me anyway, but that's, just how it's being called. I can't really change that. But then I don't need to double check that it's the right one that it's giving me. That's just wasting compute. So that's the first optimization that we do here. And since we did this optimization, we can be like, well, but do we need all the other stuff actually? Can't we just, not do any of that either? And the answer to that is, well, maybe. Now it's complaining that this, here, okay, hold on, there. Can I just, not even do anything here? It's just, we don't take any accounts. Note though, then it also doesn't do those checks, of course. It doesn't check that it has the right accounts provided, but we can be like, we don't want to check. We just want to do efficient. We don't do any checks. However, this is of course not going to work because, we're working with accounts here and we can't access those accounts here anymore. We can access the amount because that's still instruction data. That doesn't come from the accounts. That's instruction data. So we can work with that. That's fine. However, the decimals multiplier, this thing we will now need to do ourselves, or we don't. We can, for starters, be like, you know what, forget that. We're not even gonna check if we're currently transferring. We will get back to that in a second, but for now let's remove this entire thing. We will want to bring it back, but let's just optimize everything away and then be like, oh, maybe we should have kept some checks. And also the decimals, you know what, I'm lazy. I'm just gonna let the decimals be 3 because I know that that's the right thing. Ideally, I would read it from here, but I can't because I don't have the Mint account. So we're gonna hard code it for now and just see what difference in compute that would make, right? Okay, so this now, I said I would do another program, right? Okay, fine, let's do another one. Let's deploy this to the OHO and copy to the keeper. It's a little bit of additional work, but whatever. Let's deploy it to there. Okay, my optimized hook. Now, however, I also create a new token first. You know what? So the same, but this time for the token optimized. There we go. The Dochti token, also with 3 decimals. Ah, shit! Wrong transfer hook. Did I already go through? Yeah, it already did go through. Damn it! Need another one. Okay, the token optimized hook. I don't like it. Token optimized hooks. Yeah, like this one. Token optimized hook ho. There we go. Okay, so that's my token. We can SPR token, create account for it. We can mint some. And then we gotta initialize the extra metas for this hook program and this mint. Then we can SPR token transfer this token 1 to the receiver. And I gotta fund the recipient in the first one. See, that works, but only in the first one. Oh, I need to fund it only in the first one. There we go. And now it also works without the ATA. Okay, so let's look at that. So my reference was this. Now with the optimized hook, which does almost the same, except it skips a lot of the checks, but it takes the same accounts, that's the amount, and we're down to 1,793 compute units from the 5,000. Admittedly, most of the 5,000 was the deriving of one of the accounts. That is completely unnecessary. But also those checks that we removed here, checking the mint, that there is the right authority, and all of that stuff, that it's an actual token account, that it can actually read that, and, reading all of the mint information and the source information and everything. That took some compute as well. And so that's why we then also from the 4K, we got down to less than 2K. That's a reduction of 50%. However, it's not really, oh, look at that. It consumed 13379 compute units. That's nice. Nice number. Anyway, this is not quite the same for a few reasons. I mean, it's as if you say, wow, my program is more optimized now, and you just remove the functionality of it. You know, I can make the token hook even more efficient by doing this. Yeah, of course, but now you also remove the entire functionality. So, I mean, that's kind of what we're doing here a bit, because we are removing the checks. I mean, by providing those accounts, we let Anchor do the checks that those other accounts that we expect them to be. But you know, doing those checks takes compute. And maybe we don't want to do that. Maybe we just want to do those checks that we really want to do. For instance, let's say it would be good to have the correct decimals and not hard code that, because then my program would work for any token and not just the one that has 3 decimals, such that that is not weirdly offset. So we want to be able to read that from the mint account. And it's not like we don't have it, because the program is being supplied this token. Look. It's here as the second account. We are being provided that account. We just don't parse it because we ignore that. We don't let Anchor do it. So we don't have direct access to this accounts.mint anymore in the context. Right? The context here, accounts, is empty. We don't have anything, nothing there, because the transfer hook thing this thing is just empty. However, we have the remaining accounts, and that is what we're deep diving in today. So let's look at what the remaining account actually is, or the remaining accounts. It is literally remaining accounts given but not deserialized or validated. Be very careful when using this directly. Yes, we're going to be very careful, meaning that we're just not gonna care. Wait, that's exactly the opposite. That's being careless. But this is for educational purposes only. If you're actually productively working with this, then be very careful. For now, we're just playing. So, what is it? It is a pointer to account info. This is already quite high level, I would say. When I was talking with Jacob, he was like, no, you just get the pointer. I was like, yeah, but hey, it's a pointer to account infos now. I expected a pointer to bytes. I was like, I'm gonna have to read all of that myself. But no, they're not deserialized or validated, but they are account infos already. So it did check which accounts there are. Interesting. So it does have a length. Right, I could be like, there are accounts provided, and let you print that. Build and deploy, and damn it, I'm deploying too many Anchor programs. Need more sol. Okay, do that again. There we go. Okay, deployed. Again, a token transfer, one of those to a receiver. What did we just change? Nothing. What did we just do? Oh yeah, this message. I remember. Man. There are 5 accounts provided. There we go. It is already basically deserializing that. At least it's deserializing the array that we get in, or the bytes that we get in as input. Why does it need to do that? Well, because Anchor needs to know what is the instruction input. So it's gotta basically deserialize the accounts anyway, and then it provides them to me in this remaining accounts slice of account infos already. So that's helpful, which also takes compute. Like, we could go more efficient, but maybe then, you know, we just don't want to use Anchor in the first place. And the next step is gonna build a Pinocchio program, a hook with a Pinocchio program. If we take the lazy entry point, then we can be even more efficient. But anyway, we do get a slice of account infos, so we can just use the account infos. So literally we can be like, say the mint account is remaining accounts number 1. So the second account, I'm going to remove that again because that just takes compute. And then, so this is an account info. What does account info have? It has the key. It's aware of its own pub key. Amazing. It has the Lamberts, the data, and so on. So that's what the account stores. And we're interested in the data, which itself is just a reference, like a slice to bytes, and even a mutable reference. So we could even save stuff there. So we don't, we just want to read the decimals, and the decimals is a 1 byte field in the data of the token account. So instead of hard coding this, I can be like mint account data, and I guess I gotta borrow that. I'm just gonna borrow it, or I could literally say as pointer, then I don't even need to borrow that. Then I literally read field number. What's my guess? My guess is 4 plus 32 is 36. Is there something else? No, there's something else. I think that there's supplies before. So maybe plus 8. So that's 44. My educated guess would be something like 44. And then I get An index. Maybe I do want to borrow that. That seems a bit safer. I'm just gonna borrow that. And I'm just reading that from here anyway. That's all I need. So good. Decimals. That's a U8. And here you need a... Oh, this is an inefficient implementation. But yeah, okay. Let's just do it as a U64 then if you need a U64. Oh, here you're expecting a U32? Oh, okay, fine. You're gonna U32. Not like I care. And now you're complaining? Consider borrowing here. Yeah, of course. I borrow. Okay, so my educated guess, we could also check. Let you tell me the decimals. It could be that 44 is correct though. 8 bytes for the supply, 4 plus 32 bytes for the optional mint authority. I'm just gonna try. And if I get it wrong, then I read source. Let's see. Ha! Token has 3 decimals. There we go. Man, I'm so good at this. Like, I'm working a lot with those. That's why, like, if you don't understand why that's the case, don't worry. Like, why 44? I pulled that out of my head. Yes, I did not explain that at all. Because I work with tokens so much, I basically already know the token mint layout, like the state, by heart. You don't need to know this by heart, because you can look it up. Just go to Solana program token, just look in the interface, I think is the safest way even. State, and then you can look at the mint. You see there's the optional pub key. Pub key has 32 bytes. Make it a C option, it will add 4 bytes. So that's 36. Supply, a U64 has 8 bytes. So that's the total of 44 then. And here come the decimals. Is initialized is at 45. And then comes the freeze authority. So, you know, you don't need to know that by heart, but you can look it up like this. And really, like, that's why Anchor is so helpful. You don't even need to do this if you work with the proper accounts. Then Anchor does it for you and you can just say dot decimals, which is the easy way. But we're not doing the easy way here. We're doing the trying to make it more efficient way here. So yeah, we got the right decimals. I'm gonna remove that again because that's just unnecessary CU usage if you write the message. That was just for my debugging purposes. So now this should work correctly. And if I try to transfer anything less than a token, it will fail already. Nice. And if I wouldn't have the decimals correct, then, you know, it takes that, it actually reads that from that account. That I don't let Anchor parse for me. Like, no, Anchor, you don't need to do this. I'm just gonna take that info from the remaining accounts. Because that's more efficient. Is it more efficient? I mean, obviously it is. But what's my compute now? I mean, here it was 2200, but a bit of that is also the message. So doing that again without the message, but transferring an entire token. Then we are at 1800. Wow, yeah, messages and especially the formatting takes quite some compute. So yeah, I could of course also remove that, which will also save compute, but I have it in both. So we compare apples with apples. Yeah, so that was 1800, and before that we had like 1700 something. So those like 50 compute or whatever come from, you know, actually reading this. I mean, it's not free to read this. It's cheaper to hard code, obviously, but still, it's just a few compute to actually do this and, you know, get the account from here. But certainly better than having the entire mint here and decoding it as a mint, because then it decodes everything and writes it in temporary storage, which, you know, we don't really need. I just want once to read this, use it, be good with it. So that's the first thing that I want. And then I definitely, like, because we want the functionality back, I want to also be able to assert that we're transferring. So we need to bring that function back. And now we don't have this source token account anymore. We gotta work with remaining accounts. But it's gonna be pretty much the same thing as we did here with the decimals. And so source token account, and I'm just gonna check it for one account, not for both. Here I'm also just checking for one. I'm now getting it from the remaining accounts, account 0. The first one is the actual source account. So it's the same as before. And then here I don't need to do all the things. Reading it, unpacking it correctly to this state, account, get extension, mutable, transfer hook account. Ah, shit. Well, it's not gonna be so easy though. I will either need to make assumptions or read more, because I mean, that does quite a few things. Because what do I want to read? I want to read the source account. This one, the TPG, TPGo. this one, which is a token account of a token 2022 program. But it's not going to be so easy because we're not reading anything up here where it's, always the same offset. We are reading something down here somewhere. We are reading some info from the extensions. So if we check the interface for the account, this is what we have in front, but we are interested in what comes after, which is the extension stuff. So this would be in token 2022 program extension. Wait, where is it? There we go. Transfer type, transfer hook. There we go. So that's extension number 14, 0xe. And then transfer hook account is 15, 0xf. And that thing, there we go. That's what I want. That transfer hook account struct has only one flag, and it's to indicate that the account is in the middle of a transfer, and that's essentially what we want to read. It's a pod bool. The standard bool is not a pod. Define as replacement, that is. What's a pod? Hell do I know. So that's what we want to read. So essentially, if we look back into our account, it's somewhere down here, 0xf here. That indicates the extension. And there's another extension, which is number 2, I think. No, 2 is 2 extensions, and it's number 7. And number 7, if we want to look back here, is probably the immutable owner. Yeah, 7. So because we created with the associated token program, the token account got the immutable owner extension, which has a length of 0. And then we have the transfer hook extension, which has a length of 1. And that's the byte. So that's what we want to read. Currently, it's not transferring this account. The byte here is 0. However, depending on which extension is first, this will be at a different location in the account. Like if I had other extensions, then it can be somewhere else. But for now, we can just work with the assumption. And this is dangerous, kids. Don't work with assumptions because they are true in the beginning and then they might be not true anymore and you forget that you made that assumption though, and then it's just not going to work anymore. But we just say we expect the token account to have, and then the transfer hook in that order. So, and if we have other extensions afterwards, I don't care about that. If it's anything behind that, I don't care, but there must not be anything before. So let's read that byte, because that would be byte number 0xAE, because here is F, this is E. Length 175, so 174. Let transferring flag be source token account. I'm again gonna borrow the data and access byte 174. So this is a U8. This is the flag that is here, provided that it is at exactly that location. The nice way to do it is to, properly decode it, but ain't nobody got compute for that. So we're not gonna do that. And we're gonna check if it's not transferring, which means the transfer flag is anything else than 1. I mean, I could also, check that it's 0, then that would mean false. If you interpret it in C, then any positive value is true, but I know that the token program sets it to 1. So if it's 2, for instance, then I know that I'm reading the wrong byte. So I can be more specific and really check for is exactly 1. And if it's not, throw the error. And then I say, yeah, we're currently transferring. Great. Let's do that. Oh, I forgot to borrow this. So yes, I'm working with that assumption so that I don't need to do this stuff, which, saves compute. So I guess that will do. Let's build, deploy, and do a transfer. Will it? Looks good. The hook didn't complain. So we're at 1835. And we are currently transferring. So it read that byte correctly. We need a bit more compute because we're also printing more now. But whatever. That's 100 compute for doing this check and doing this print. It's fine. We are currently transferring. So that seems to work for that specific setup. Again, working with assumptions here. But that's already it. Like, that's the same functionality almost. I mean, again, ignoring some checks. But essentially, we do check that it's currently transferring. We do read the mint and we do check that it's transferring 1 or more tokens. So as a minimal example, that's fine for my transfer hook. I would argue that I don't really need to do all the checks that I left out. What checks did I leave out? Well, that this source token account has this actual mint and that the transfer authority and so on and so on. Yeah, I mean, do we really need to check this? I mean, depends what you do, right? In this example, we don't need to check this, but in this example, we also really wouldn't need to assert that we're currently transferring. Even that check is unnecessary because all that we do is making sure that at the transfer, we check that the amount is larger than 1. That's the entire point of this transfer hook. So might as well make it as efficient as possible and not do all of the deserialization and checks. And we know that this is being called whenever a transfer happens because the token program guarantees this. However, we cannot guarantee that no one else calls it as well. And if we don't care about that, then that's fine. But the whole reason why we did this is such that we check that it's not invoked through something else. However, if we want to make sure that this is really called correctly from the token program and I'm not being messed with, then we would need to do more checks that it's actually token accounts. Because an attacker, for instance, could go ahead and put any 2 accounts here, you know, the mint decimals. Actually, that's a good example. If we're being called from the token program, then we can guarantee that it is a token mint here, this account. So we don't need to double check that. It's just if somebody else calls our program, they could provide any account, any mint here. And then my check would go through. But, you know, do I care about this? In this case, not really. But again, in this case, I don't even care about this. So why did I add that check? Well, just to go through it how I would do it with the remaining accounts. But this doesn't stop anyone from calling the hook anyway with whatever accounts they want, right? They just need to have any account that at byte 174 has written a 1 and at byte 44 of the second account has written, you know, whatever decimals. It could even be 0 because with 0 decimals, the minimum is 1. Then they could go around that. But again, because the token program already makes sure that it's the right accounts, I don't see why I would need to do those checks here. If I don't mind that anybody else calls the program with whatever accounts, I don't care about that. I just want it to work as the hook, and that it does. Then I don't need to do those checks. I don't need to ensure that it's the right mint, the right token account. All of that, it's nice that we do it, but it's kind of unnecessary, especially the deriving of that account. So in my opinion, even this is unnecessary. Also, this is unnecessary. This is sufficient that it works perfectly fine as a transfer hook. And I don't even have security concerns because token 2022 makes sure that it's the right accounts. And so with that, I can get it down to 1,730 compute units from the initial 5,500 that we started with. So that's an improvement. And I could get it down even further by doing more optimizations. For instance, you know, not using Anchor and using Pinocchio, which might be the topic of a future video. Also, topic for a future video, while we're analyzing those anchor things, maybe it would be really interesting to see what that actually does, like what's happening behind the scenes if you write that macro. What's actually happening there? If I say account mutable or signer, what's happening behind the scenes? I want to expand that. Here it says it anyway for that, but that derive helper, what does that do? Maybe I want to do a deep dive on that, but we're not going to do this today. We might do this in a future video. Let me know if you want to see that, if you're interested in learning about Anchor and better understanding how all of that works, what it actually does behind the scenes, because those macros, they're just here to make it easier for us. This is even deprecated or something. Because Anchor is trying to get more efficient and Anchor is really nice for beginner devs. Yet at the same time, if you really want to be efficient, then you might want to use native Rust or Pinocchio. Pinocchio is currently what I would recommend that you use if you want to write efficient programs. So if you're up for that, make sure you subscribed. And yeah, I hope you learned something. I hope this makes more sense. Now, it's super easy to work with those remaining accounts in Anchor. I thought I would have to struggle way more, but no, there already is an account info. slice. So that's perfect. So if you're saying, I don't want Anchor to do all of those checks because I don't need them, and Anchor does those checks as soon as you write those accounts, maybe you just want to go and use the remaining accounts instead, or make them all unchecked. That has a similar result, but even still that adds a little bit more of compute. But then if you work with them anyway, then it comes down to the same thing pretty much. So yeah, this is how we work with remaining accounts or unchecked accounts to save some compute, because that's what you want to do. Okay, good enough. I think I'm happy with that video. Here's some other ones that you can check out, and I will see you in the next one, where we have a look at other things. Or maybe we write that Pinocchio program. I really want to write that Pinocchio program. Maybe I'm going to do that next. See you then. Okay, bye.